Hey everyone, in this session, let's explore frequently used methods in NumPy array. Whether we want to search an element from an array, we want to sort all the elements of an array, changing the shape of an array, or finding unique elements from an array, we have functions for all of them. There are a tons of functions to perform all these operations in NumPy. We have listed few of the important functions here. Using unique, we can identify all the unique elements of an array. We have sort method to arrange all the items of an array. We will see what is the use of shuffle function, resize and ravel functions. Using where function, we can even search a particular item from an array. We have a way to perform binary search on a sorted array using search sorted method. Remember, there is no specific method for filtering items from an array. However, we can pass a filtering condition within the square bracket of an array to filter the items from an array. Let's go to the Jupyter notebook and write some code to understand all these operations with some examples. I am in my Jupyter notebook now. Here we will first import NumPy package in our notebook and create an example array so we can perform a number of operations on top of this array. Unique is a function which returns all the unique elements of an array. As you can see here, the number of items within array are more. Only the unique items are getting displayed once we run unique function on top of the array. Using sort function, we can even sort all the elements of an array. Sometimes in data science, we need to shuffle the input data. There is a shuffle function by which we can shuffle all the elements present within an array. If you see now under sorted underscore array, we have all the items in sorted order. If I run shuffle, it is shuffling the items randomly. So if I run multiple times, every time shuffle will give us a different order of element. Let's see what was the content of our initial array. Now we will try to resize this one-dimensional array to a two-dimensional array. Resize takes two arguments. One is the array, another is the target shape of the array. Let's run this to see how one-dimensional array is getting converted into a two-dimensional array with the help of resize. Here we have 3 rows and 3 columns. Ravel is a function which flattens an array. Our new array is of 3 cross 3. Ravel flattens the whole array into one dimension. This is also a very important operation we perform as data scientist or a machine learning engineer. We can perform both linear search and binary search on an array. Where is a function by which we can perform linear search. Where takes a condition as its input. It checks each and every items present in an array and evaluate this condition. If the condition is true, it returns the index number of that element. If I run this, notice here, I want to search 4 from this flattened array. 4 is present in the first index, 4th index and 6th index, and that is the reason it is returning 1, 4 and 6. It also provides the data type of those items. In this case, it is int 64. Using this condition, we can get indexes of all the even numbers present within flattened array. If you see, 2 will not be there because 5 is not an even number. Apart from 5, 9 and 7, all other numbers are of even numbers. We have an efficient version of searching an element from a sorted array. Using search sorted function, we can perform binary search on an array. This will also give you the index number of the item present within an array. Let's now understand how can we filter items from an array. There are 2 ways. Either we can pass an array of booleans as filtering condition of an array. Wherever there are true values, only those items will be within filtered array. In this case, as we are taking sorted array as our input array, only 2, 8 and 10 will be displayed after this filtering operation. We can even pass a conditional statement in order to filter items from an array. Based on this condition, only The items which are divisible by 4 will be stored within filtered array. If you see the source array, we have 4 and 8. These two items are divisible by 4. Hence 4 and 8 will be stored within filtered underscore array. Let's run this to validate our understanding. In this session, we realized there are a number of functions to perform a lot of operations on top of NumPy arrays. Though there is no specific function to filter items from an array, we can pass the filtering condition within square bracket in order to fetch filtered items from an array. Hope you have enjoyed this quick session on NumPy array functions. Thanks a lot for watching this video.